Welcome to Embedded, the show for people who love gadgets. I'm Alicia White, here with Christopher White and our guest Mark Johnson. You might know him as Flatcat. He was the creator of an open-source 3D printable Raman spectrometer using Raspberry Pi and off-the-shelf components.
Hi Mark, thanks for being on the show today.
Hi, thank you for having me.
Could you tell us a bit about yourself?
Sure. Boy.
Where to start, huh?
I am, I practice this with my friend, and I'm so bad about talking to myself. I'm talking about myself.
Okay, let's start with the easy things. Are you a hardware engineer or a software engineer?
I guess both, actually, as much as the other, because I don't do either for a profession, so.
You don't do either for a profession?
No.
What do you do for a profession?
Probably more software, I guess. I do software at work.
Okay. And I know you didn't want to talk too much about your specific work stuff, but how long have you been in the industry? Like 5 years, 25?
Oh, probably closer to about 18 years.
Okay.
That's about.
And do you do a lot of hacking at home?
I do. A lot.
What kind?
A lot of hardware. And I fill in the gaps with the software. It's like everyone else pretty much.
Why? I mean, why do you, if you're professionally more of a software engineer, why do you do hardware hacking instead of software hacking?
That's a good question. I guess because I'm more of a visual and I like to have something in my hands when I'm done.
Yes, I like that feeling of here is this thing and I made it.
Yes. It's a greater sense of gratification that way, I guess.
Did you go to school for hardware or software engineering?
I did not. Yeah, it's all self-taught.
Wow.
That's impressive. So how did you transition into doing that from wherever you were?
Well, my dad was an engineer, and he worked for the government, so I kind of naturally was introduced into it there, and I started with electronics when I was about 7, I think, and kind of worked into both because I started off building simple circuits at that age, and then he encouraged me, and I built an Apple II clone when I was young, and wrote, stuff for that, and just kind of progressed.
And yet you didn't end up going to school for it.
No.
Interesting.
So the Raman Pi, the spectrometer,
Mm-hmm.
For people who are not familiar with it, what is it?
Well, we should back up a little bit, right, and explain that it was the Hackaday entry.
Well, yeah, but I figured we'd get there.
Okay. I just didn't want to go backwards.
So it's a Raman spectrometer. It's the difference between it and a normal spectrometer would be that it uses a laser. It contains a normal spectrometer. It uses that for the end result, but the laser, it basically you shine the laser on the sample, and based on whatever compound it's testing, then the light is re-emitted either as Raman scattering or through Rayleigh scattering. And the Raman scattering is what we're interested in, but the difference is about 1,000,000 times more powerful for the Rayleigh scattering, which is just reflected light from the laser. And then the Raman scattered light would be shifted in frequency, and then we measure with the spectrometer portion what those frequencies coming back are. if that makes sense.
Yeah, so for somebody with maybe a advanced high school physics background who understands, has heard of Rayleigh scattering and various kinds of spectrometry, how would you explain the difference of what you're trying to interrogate with this versus a standard spectrometer? Or what's cool about Raman spectroscopy versus standard spectroscopy, I guess.
And then after that, we're going to define spectroscopy.
Well, I said advanced physics.
I know, but I didn't get that till college, so
Okay,
I wanted
that's fine.
to go back a little bit.
Well, maybe we should start there.
Yeah, actually the funny thing too is I have no experience in either, like probably a month before I started the project. So
Wow, okay.
yeah, everything I've learned about it, I've learned on the way.
So before we get there, then what turned you on to it?
I have a need for it, so used one on eBay or wherever else you want to buy one is there's several tens of thousands of dollars, so a little out of my scope.
I have wanted a spectrometer for a long time. And so you mentioned a little bit about what it is. It uses light in certain frequencies to identify the materials of something. And so
Right.
there are mass spectrometers, there are gas spectrometers. Really what we want to do is not the ones that burn the sample, but instead the ones that shine lights at it and don't hurt the sample, but tell you what's inside of it.
Right. So there's absorption spectroscopy and emission, right? So measuring like starlight would be emission. So you're measuring the different colors that are coming at you, and absorption would be where you have a source light with a calibrated light source that you shine on something, and the reflected light is what you measure. And this is closer to that.
Because you're putting light in and then looking at what happens.
Right. We're putting a monochromatic light in, so we know what the source light frequency is. And what I'm looking for with it are bond angles. So that's the interesting thing about Raman spectroscopy, is that you can measure things like the vibrational state and the bond angles of the molecules that you're looking at.
Instead of just, say, their composition.
Correct.
A lot of spectrometers, that's what they do. If you put in a sample of alcohol, it tells you that it has nitrogen, oxygen, carbon.
Right.
But it doesn't tell you how it's combined. And if you have a little bit of phosphorus in there, the difference between alcohol and explosives is not that high. At least not if you're just looking at what the atoms are. But with
Right.
Raman, you're looking at how the atoms are connected together, right?
Yeah, and so it'll tell you the state of the vibrational state, because like water, as an example, has multiple states that it can vibrate. There's bond stretching and the angles, and there's a number of ways that it can change, and it'll tell you those differences.
Why would I care if my water's molecules were stretched?
There are a lot of reasons. I mean, Raman spectroscopy is important in like biological research. In fact, a lot of the followers I've gotten from Hackaday are do-it-yourself biohackers. Something I didn't actually I knew a little bit about before I started, but I didn't realize it was such a big thing.
It's interesting and terrifying.
Yes. But yeah, so I mean, with genetics and things like that, I guess it's a big thing for them.
Yeah, there was another entry that was really interesting about polymerase looking at genetic features and being able to do that at home, which, I don't know, I always thought you needed a lab to do that.
Yeah, I guess there are a lot of it's a growing thing. People with their own PCR machines and
Yeah, because the bugs there won't. Wait a minute, there'll be actual bugs. So Raman spectroscopy requires a finer grained laser than the.
Well, all lasers are monochromatic.
Yeah.
But usually you have for other spectroscopy, you use a broadband light source.
Oh, right, because you actually use the white light. You want to see everything.
If you're looking for absorption characteristics, when you look at what happens to the material, it'll be missing certain lines or emitting certain lines.
Well, I mean, one of the things that kind of made spectroscopy make sense to me with the broadband, not the Raman, but is if you look at the Earth and the sun is your source, water absorption makes it look blue to you, and white for snow, and all of these colors that we know what they mean, because if you aren't looking at something that's painted or colored, you're looking at a natural thing. Its color tells you a lot about it. Green probably means there's chlorophyll.
Right.
And so when you're doing that at a very small level with samples on your desk, it's a similar sort of thing, except you're looking at the actual spectra, the frequency that you're seeing very fine grain instead of these ginormous, it's green from outer space. So that's a much bigger thing. But Raman spectroscopy, monochrome light, and you look at the bonds, what is the analogy there? Is there an easy one, like my whole sun world analogy? My husband's saying, no, absolutely not. He's looking at me like, you could have asked a more difficult question, but it would have involved math.
Yeah, well, I mean, so basically the thing with the Raman spectroscopy, when you shine the laser on the sample, you're going to get, 99.99999% Rayleigh scattered light back. So it's going to be all, except for 1/1,000,000% Rayleigh scattered, which is right back at you with the green light or whatever frequency you're using. And then that tiny fraction is going to be shifted Raman light. So the green light will actually, for water, for instance, will turn red. And that's what you're measuring. The shade of the shift in frequency is what's important to you.
And so you have to filter out the light color you put in.
That's what the notch filters do. They filter out all the green light and only allow that tiny bit of Raman shifted light through.
That's the beauty of using a laser, is you can do that.
Yeah,
because you know what your monochrome frequency is.
Yeah, and that's why it's important to have a laser that's stable. So, temperature and other factors can cause the diode lasers to shift in frequency, and that's why I included also a pass filter right in front of the laser. It only lets the 532 nanometer light through. So you do everything you can to make sure that that's as stable as possible before it hits the sample.
Well, one of the things about your project was that it was relatively low cost. You said you didn't, eBay might have helped you with the application of a bucket of cash. How much does a stable laser like this cost?
The one I settled on was it was about $90.
So that's garage invention land, yes.
Yeah, so it's 150 milliwatt is what they list it as. I haven't measured it really, but it's pretty bright.
Do not stare directly at the laser.
With remaining eye.
With remaining eye.
Yeah, it would definitely do some damage.
So why did you do this? I mean, you said you had another thing you wanted to look at.
Yeah, I'm working on a couple of other projects that aren't really open source.
Uh-huh.
Oh, okay.
So this came up as a need because I needed to measure some output from that. It's measuring the waste from that, but it's important to know.
All right. That's intriguing, but clearly not something you want to spend a lot of time on.
It's something I hope to release in the next couple of years. It's been a long process.
Yeah, I can imagine if you have something you wanted to do and the solution was Raman spectroscopy. For one part of it, that perhaps it's a long-term thing.
Yeah, that's the irony too. Is the Raman spectrometers is actually a very small part of the whole thing.
what made you decide that now was the time to get started? Or last April, I guess.
With the Raman spectrometer, Raman spectrometer.
You can say ramen pie. I bet it's easier.
Yes, Raman pie. The time was about right for where I was at in the other projects and everything that I needed to get that in line. I had finished other parts of it that were actually more complex. And the Hackaday Prize, I was talking to a friend of mine, and the ramen pie seemed like something that other people could benefit from. And there was nothing really about it that, is special, really. I mean, there's already ramen spectrometers out there. So I was knocking around the idea of sharing it and making it open source. And then the Hackaday Prize came up, and I started posting it on there. And Mike from Hackaday sent me an email and said that he'd like to do a bio on me, and it just kind of went from there.
That's Mike Stish. He was on the show a while back. And your bio on Hackaday was similarly cagey to how we've been today. You didn't have your name anywhere. For a while, as I asked if you want to be on the show, I was addressing emails to Flatcat because I had no idea. Why are you so cagey or shy?
It's
That's
more
a good
of a
question to
shy.
ask shy people. Speaking from experience, it's always nice. Yeah.
Well, I grew up in a very secretive environment, I guess you could say, because my daddy did work for the government. So there was always that, unless people need to know something, then you don't need to tell them kind of attitude about things. And it's just been ingrained in my life, I guess. And until recently, I kind of lived by that. So it's a big step for me to have shared something like this.
To get into open source after that kind of experience.
Yeah, it's different.
And
It's a little unnerving.
yeah. And protecting your identity and privacy is tough in the online world these days.
It is. It's difficult.
You did a really good job because I couldn't find much at all.
Yeah.
So back to Hackaday. What was the whole Hackaday Prize thing like from your side? I mean, from my side, it was pretty different, but because I got to sit and read everything and say, wow, that's neat. But for you, I mean, you were working on things.
Yeah, so that was an experience. I don't mind deadlines. I work with deadlines a lot anyway, but I have to say that it was difficult doing the documentation and working on the project and meeting deadlines and doing a video and and everything all by myself. Yeah, because I mean, not to say anything about a lot of the other projects, but I had a lot to do.
Well, and you started at the beginning of the contest. You didn't have a lot done before the contest started.
Yeah, not a lot at all.
Well, and these kinds of projects like the one you took on, I think the only thing missing is motors, right? You didn't have any moving parts, but you had optics and cameras and computers and lasers and
there's two stepper motors.
There you go. You had everything.
Bingo.
Yeah. Yeah, there's one stepper motor for the filter wheel and another one for the tray that opens the cuvette door.
So was it hard to stay motivated, self-motivated?
Not at all, actually. That's something I don't have a problem with. But prioritization is it was a bit of a challenge, making decisions about what I needed to get done before the next deadline and what kind of documentation needed to happen.
Well, Well, they had a few rules, like you had to have a couple of project logs and you had to have a description and a picture.
Yeah. I don't have trouble with logging things that I do. I probably document more than I think most people do.
It was one of the things that drew me to your project, that I really felt like I could build this. And that was neat. And so often with engineering things, you get the idea that, wow, that's neat. I'm so impressed that person did it. But you don't get that other feeling of, and I feel like I can too. So you did a great job documenting.
Sometimes it's like reading a project log. Sometimes it reads like a patent. Like, for those skilled in the art, you could reproduce this, but you have to actually know how to build it already before reading. So
yeah, that was one of my major goals with this, was to make it so that just anybody could put one together.
So we mentioned that it sort of was a multidisciplinary project, has optics and lasers, motors, computers, all that good stuff, cameras. How did you break down and prioritize your development of it?
It was kind of a natural progression, I think. I started with the 3D models for the plastic parts and kind of hammering out the design on that. And if you look at the history I started off with a completely different design, actually. It was more of an optical bench setup. And the more I worked on that and the more people were talking on Hackaday, it came more evident that it'd be sturdier and more effective to switch to like the tubular kind of design like I have. So I went that way, and then I just kind of worked out from there. I already had an idea of the electronics and everything that was required, although I did start off with the naive thought that I was going to use the Raspberry Pi camera to do it. And that changed quickly.
Getting that camera to do what you want is kind of tough.
It is. The biggest problem I had was just the exposure time, and it didn't work out great. Although I think it would work okay for a lesser version if I used like a transmissive grading instead of the reflective grading. It would make the whole thing a lot cheaper and more available to people.
You only need one line, really, of camera pixels, right? To read the spectrometer. You don't need a 2D camera, so it seems like something of a waste to use a normal camera, but they're probably actually cheaper because it's made in higher volumes.
Well, and the other problem with the CCD on the Raspberry Pi camera is the filters they have. They actually have a filter in front of the elements, so you're not getting a true representation. And
I know they have the NOAA cameras. I've got one around here somewhere, but more filters than that?
I'm not sure. I haven't. And that one came out about the same time I started on all of this, so I don't know exactly if that one has all the filters. I wouldn't imagine it does, since it's infrared.
Well, I don't know if those cameras have some non-linearities too.
Yeah.
That you'd have to either correct for or live with.
Yep. So yeah, that's all of those things factored into pretty much why I settled on a linear CCD.
It looks like you got about a $15 CCD linear array detector from Toshiba.
Yep. Yeah, they're fairly cheap. They're not the easiest things to control, but...
So doing things with an optical bench can get really, really expensive quickly.
Yes.
How far did you go down that path before getting to 3D printing?
Not far at all, actually. I started off with the 3D printing, actually. I started making... The earlier designs were basically just plastic copies of, you bolt to a flat table, and that didn't last long. With vibration and everything else, the alignment wasn't very good, so I abandoned that pretty much as soon as I finished it.
And so when you look at the pictures on your project, you have these 3D printed tubes, which is where the light goes, and then some optics placed in certain locations, mostly mirrors. And it's all very contained. It's all one giant thing almost, and not like an optical bench where you have holes all over and little tubers you put here and there, and they're not connected, except that they're all sitting on the vibration isolated platform usually.
Yeah.
The 3D printing is, I am so interested in that because anytime I've done optics in the past, that optical bench has always been really tough to use.
Mm-hmm. Yeah, the reason I went with the tube design was it seemed like it was sturdier for the printed plastic parts. It also eliminates environmental
dust.
Yeah, dust and stray light from other sources. It seemed like a really good way to go for that. Plus, I had in the back of my mind eventually of trying for aluminum parts, or maybe like a HDPE, like milling them out of aluminum or casting them, whichever's a better way.
This leads me to one of my questions about the 3D printed parts is, I don't know how sensitive placement is for a Raman spectrometer. You mentioned when you had it on the bench, you had vibrational effects, which caused trouble. Presumably, thermal effects also would introduce problems, right?
Yes.
So, are the plastics that 3D printers produce, are they stable enough that you can actually build your optical train and be confident that it's not going to shift?
Yes and no. Obviously there's trade-offs. So I think for the home lab, it's good enough. I haven't had any trouble really with alignment. Once you do get it aligned, it seems pretty stable. And it's probably a good idea to let it, sit for a couple hours while it's stabilizing.
Right.
And that's part of the reason I was thinking forward to the aluminum and everything else for people who are more serious about it. That would be a much stabler platform.
How did you design the optics so that they could be 3D printed?
I used OpenSCAD.
I was going more for how did you know how to do that?
I didn't.
How did you figure it out?
A lot of Google. So yeah, and a lot of trial and error. I probably have 4 or 5 copies of each piece that I've made mistakes. So a lot of trial and error, and just Google.
How did you get everything to align?
I'm fairly lucky, I guess. As far as alignment with at least what I've put together, the mirror on the laser is the most critical point. That and the beam splitter. And I probably need to do a little bit more work, but the adjustment screws that I have on the mirror help a lot. So I want to actually do some refinement eventually and incorporate a little more for fine tuning in that way.
So it looks like on the picture on your project page, it's a 3 Allen screw kind of wiggle it back and forth adjustment.
Yeah.
Okay. It's similar to how telescope secondary mirrors are adjusted, so it doesn't seem unusual.
Yeah, it seems to work.
So what you walk up to Google, you say, Google, I would like to know how to make optical things with my 3D printer.
Hours and hours of searching. Yeah, so for the 6 months or so that the contest was going, I probably got average of 3, maybe 2 hours of sleep a day.
Wow.
My goodness. I was going to ask you about how I mean, if this was like a contract you were doing, about how many hours would it have taken you? And now I'm a little afraid of that number.
Unbelievable amount of hours.
Did you take time off work?
In certain points, yes. I took probably a total of 2, maybe 3 weeks of work off to finish it.
Sophie was talking to us a few weeks ago about makecations, where you stay at home and make things. That was a new concept to me. Was it a new concept to you?
No, unfortunately. Yeah, it's kind of business as usual.
Did your coworkers know about what you were doing?
No. No, pretty much no one has any idea.
Or they still don't know?
No.
What did you tell them about your lack of tan when you got back to work?
Well, I work from home, and most of my coworkers are out of state, so it doesn't matter.
Mm.
Wow. Now I just want to go and tell them all. It's a good thing you didn't tell me where he works.
That's probably why.
Yes, exactly. So back to Hackaday, you had the semi-finalist video.
Ramen Pie started as a project to fill the need for another project that I'm still working on. I had to obtain the bond angle and ramen chefs for samples that I was producing. That called for a ramen spectrometer, and access to one is financially prohibitive. As even
It is that your voice?
It is.
Did you speed it up?
I did.
How much?
I think it was about 25%.
That's not too much. You must have still been talking pretty fast.
I was. I recorded it in sections and I sped it up. So yeah.
I have to get this much said in 5 minutes.
Yeah, that was the thing, because the requirement was that it had to have more technical information, and there's a lot.
There was a lot, yes. We weren't sure if it was modified voice. You know, you typed it in the computer and it said it really fast for you.
Yeah, the first and the third video were computerized.
Why?
Again, with the I was just uncomfortable, I guess, using my own voice.
It's a good solution. I mean, both the speeding up and using the voice generators, you know? And so you made it to the finals and the top 5. And did you dream about going to space?
You know, when I first heard the contest, and the trip to space, I wasn't really thinking about like Virgin Galactic and the other options that are out there. I was thinking more of the Soyuz.
Yeah, that's what I would have been picturing.
Yeah, with that, I would definitely have gone to space. But yeah, I looked it up, and yeah, I didn't think they were going to pay that much to send somebody. So
Yeah, that's a few tens of millions now right now.
But you won, you won the skydiving prize. Is that right?
I think, yes, I did.
Are you going skydiving?
I probably am not. I'm a pilot, and I fly around my local area quite a bit, and there's 2 or 3 areas that are popular for skydiving, and that's pretty much what made the choice for me that I'm never going skydiving.
Because you see the injuries, or
Why would you jump out of a perfectly good airplane?
Partially that, and they tend to jump right in the most popular place to fly north and south in this area, and people when you're doing yeah, when they're not on frequency and you're flying, and it takes you a second to figure out what that dot is in front of you.
This reminds me of playing Crossy Road.
Yeah.
No more Crossy Road.
Yeah, I don't want to end up on anyone's windshield.
So what other attention did you get by doing this project?
Wanted or unwanted?
Yeah,
Well, yeah,
a
there's
lot,
some of that.
actually. Way more than I expected. RaspberryPi.org wrote an article. there's been a few actually, and Twitter has I've had a lot of interaction on Twitter. I put something on publiclab.org, and it was there for a couple months, and then one day I think I got 17,000 views in one day.
Jeez.
Yeah, so a lot.
What do you think is driving that interest? I mean, I knew theoretically what Raman spectroscopy was, but I didn't really have a notion of its use in industry or its importance. Is there some application that you think people are looking specifically for?
I think the do-it-yourself bio is very popular. Yeah. Other than that, I see a lot of people that are interested in gems, like rocks and things like that.
Thanks for clarifying.
Yeah.
I was thinking about sweat instead of rocks, so it's gems. Not
Yes, gems like minerals.
Do you think are you going to stop with what you've got and it meets your needs, or do you think there's further to go where you could drive it even lower cost and easier to make?
So yeah, I think actually with the amount of interest I've got and the amount of people asking for kits and things like that, there's definitely it merits a second version probably.
I mean, it almost seems like you could get this handheld after significant development, but it doesn't seem out of the realm of possibility.
Right.
Unless the optical terrain has to be a certain length, I don't know.
No, I think a handheld version is probably possible. I would have to probably learn a little bit more.
Sure.
Because, I think some of those, I think they use fiber optics and things, and interfacing with that is different. But I don't think it's something I can't do.
Yeah, the nice thing about free space optics is you don't have to splice things.
Right.
Cleave them correctly. And a fusion splicer for fiber optics is pretty expensive right out of the gate. So
yeah, and that's something I've been really trying to do. Is it's the biggest drive has been cost on everything.
Right.
That aluminum's gonna have to wait then.
Yeah, actually, I want to. One of my next steps, I think, is I want to go over the whole design and make sure that everything is in check and that it's going to be completely accurate. And then I want to kind of refine it so that I have better things for alignment and things like that. And then there's a lot of work to be done still on software.
Are you going to make kits?
I'm looking at it, yeah.
Are you going to monetize this somehow for yourself?
I'm thinking about it. There's been a lot of interest from people for kits. So, yeah, I think if I do kits, they're probably going to be aluminum and not plastic. Because
or at least injection molded.
Something, yeah, or maybe, something along that lines. I'm looking at the different kinds of ways to do things like that and how much it costs. I think injection molding is kind of expensive.
Yes. Oh, it's cheap to do one. It's cheap to do the 10,000th.
Yes.
The first 10,000 costs a lot, but that once you get after that, you're good.
Yeah.
Is there any chance this is going to take over your life and become a job?
Maybe for a period of time, that's a possibility.
Is that exciting, terrifying, wonderful, strange?
I think all of those things together. Yeah, because I mean, it's something new for me. I had no expectations of this. I didn't expect to make it to the quarterfinals, let alone the final five, and I didn't expect the kind of interest that it's gotten. And yeah, so definitely making kits and things like that was. I figured when I did it that I'd just share it and couple people would be, hey, that's neat, and then I'd go along with my life. And
reevaluate.
so yeah, but I mean, it's a good thing. I'm very happy that there is an interest and that it can help people, because that's why I wanted to share it. And
so you learned a lot about Raman spectroscopy and mechanical and electrical, and you do software. And have you ever shipped physical things before? Because manufacturing, there may be some speed bumps ahead.
Yeah, I think there probably are going to be some speed bumps.
It's another whole area to learn.
Yes. Yeah, luckily that's where my friend comes in, is he's good with that end of things.
Well, I look forward to hearing about kits. That certainly changes the way you have to look at it all.
Yes.
I mean, like I said, I felt like I could follow your instructions. They were really good. Has anybody tried it?
There are several people actually in the process of building them right now. So
isn't that gratifying?
It is. It really is, actually. I get emails from people that are in the process of building it, and they have a quick question or whatever, and I help them out, and they seem very happy. So, yeah. It's a little strange.
That's been one of the things I've found with the open source community, is that when somebody takes what you've done and builds it themselves, there's a real surrealness to it.
It is. Yeah, it's very interesting to think that there are other people with something on their desk that I designed.
And who care about, what you made, and care enough about it to either take it the next step or take ownership of it in some way themselves.
Yeah, definitely.
So you mentioned software, and I did want to talk about the Raspberry Pi portion of it a little bit. One of the first questions is, why did you choose that as the platform?
Especially because you've got some other processors in there.
Yeah, so availability mostly. And the fact that when I started the project, I was thinking of using the camera module. So that's most of it. Plus, it's a Linux platform and it's super cheap. So all of that together was the biggest reason.
Did you need a lot of CPU power to process things, or is it relatively straightforward?
In the beginning, with using the camera module, I would have, because processing the images, and layering them and stacking them a way that you would have needed to would have taken a lot of processor. As it stands, most of the processor time is taken just by retrieving data from the internet and stuff like that from the databases.
And that's to compare your signal against known samples?
Yes.
How do you qualify the setup? How do you say, okay, this is working? Do you need
calibration?
Right. Did you take okay, I know what this thing is, and this is what the spectrum should look like, and it's shifted this way or that way or attenuated here, so that means something's not right. How did you go about testing your design?
So yeah, I mean, you take basically a known sample, and you compare the peaks to the database sample. And I'm still kind of in the process of doing all of this part. Mine right now, I wouldn't claim that mine is calibrated in a reliable way quite yet, because a lot of the software is what's required to do that, and it's still pretty young in that sense.
Is that the sort of thing where you could have not quite a perfectly aligned and perfectly set up optical system, but you could calibrate it with a known sample and then adjust for it in software? Would you rather adjust for it in software or make adjustments to the system?
It's pretty evident when you have the hardware aligned.
Okay.
And yeah, I mean, that's pretty straightforward. And other things you can make an adjustments in the software for pretty well. So eventually I would like to actually put a motor on the CCD so that I can slide it just a tiny fraction of a millimeter from side to side. That'll help with both calibration and with resolution, increasing the resolution later. So there's a lot of advancements I can make in a lot of areas.
That's the trouble, is choosing which one to,
Yeah.
what to do next, right?
Then you end up with the $10,000 spectrometer on eBay, which isn't
Yeah.
ever what you wanted.
Exactly.
Back to Mike Stish's bio on you on Hackaday. It mentions a surplus electronics store in Silicon Valley. Which one?
Yes. So yeah, I worked at Weird Stuff Warehouse.
Oh,
Oh,
God.
awesome. How did that deform your youth?
Oh boy, it was a popular destination for me when I was young and not working there, and then getting to work there was an adventure. That was probably the best job I've ever had.
So I think we've talked about Halted on the show, and that's a surplus electronics store, and Weird Stuff is similar
It seems like Weird Stuff had more recent things,
and fewer components.
not things going back to the 60s
Fewer
necessarily.
tubes.
Yeah. A lot of semiconductor equipment, I thought, but
And yet we have friends whose Saturdays consist of going either to the Dianza flea market for electronics, or to Weird Stuff, or to Halted, or sometimes all three, depending on brunch and lunch and who else they're meeting with. I suspect the customers at Weird Stuff are almost as interesting as the...
Weird Stuff.
Thank you. I was not going to get past that.
Yeah, I mean, it was like I said, an adventure. There was a lot of interesting things there.
What's your number one story from working there?
Oh boy, it has been a very, very long time.
That means that, we won't recognize any of the names you use.
Yeah, boy.
Is there a Woz story? There should be a Woz story.
There was one popular thing about working there was trying to spot Steve Wozniak. Because every time we thought we saw him in the store, he'd run out. So
He's like the ghost of Woz.
could never quite pin him down.
You've caught me.
Yeah, so there was never a definite sighting that I knew of.
Moving along, what's a fuser, and does it contain ectoplasm and house ghosts?
What?
He talked to Mike Stish about fusers, and when I looked at fuser.net, an open source fuser, it seemed very Ghostbusteries, which we did talk about on the show last week. So it was sort of, continuity of sorts.
So yeah, that's an interesting topic all itself. They're based on the Farnsworth fuser, Philo T. Farnsworth.
Oh, I think I know what this is.
Yeah, so I guess he invented television, right?
Yes.
Yeah.
So one of his projects was the fuser, and it's basically it's a how do you describe that? It's a vacuum chamber that you put a lot of voltage into, and it's got a grid inside of it.
Oh, I know what this is. Why would you do this?
They're not the safest devices on the planet.
That's why I'm asking the question.
I've always been fascinated with high voltage. I've had a lot of experience in the past with like Tesla coils and things like that, so I guess it's another natural progression for me.
So basically, a fuser is a chamber you can make to do nuclear fusion.
Yeah.
And you can't do anything useful with it. I mean, you can do useful things with it, but it's not going to generate power for you.
Right.
We've not reached ignition
But
yet.
what it will generate is a lot of neutrons,
Lots. And a lot of X-rays.
which are great stuff to stand in front of. But they're really pretty.
Yes. And it's a hobby thing,
So how much current have you passed through your body? What is the largest amount
Oh boy, I think the first time was electrocuted when I was like 2 years old.
The first time.
I knew when I heard about fusers that was going to come out.
Oh yeah, I crossed two bobby pins in a light socket when I was 2 years old. So there's that.
I seem to remember something with a fork when I was younger. Yeah.
Yeah.
You have to learn not to lick the light switch.
I accidentally touched the output on my Tesla coil when I was 17. That hurt.
Hopefully that's just a high voltage, not high.
Yeah, not a lot of current, but
Still
yeah,
hurts.
that hurt.
God, I'm still looking at this fuser thing.
I've lost Christopher.
I don't know if I want to build one or find out where the closest one is so I can move further away.
Yeah, to think that people are building those in their garage. Oh.
So back to Hackaday while he's off surfing the web. Was there something about the contest that was more difficult than it looked? I mean, you mentioned deadlines, which I honestly hadn't really considered, because my deadlines were read stuff after your deadlines, they weren't as arduous. But was there something else that was just neat or odd or more difficult than you might have expected from the onset or from being a outside of it?
I think the documentation and the videos were probably harder than actually building the project, at least for me, because the videos, there's something, I don't know, I have to do something and feel good about it. So I didn't feel good about the third video at all. That was a horrible example. And the second video, I didn't feel good about it either. But the deadlines, I had to make certain concessions to get everything done in time. So yeah, I think that was probably the hardest thing for me, was making the concessions to meet deadlines with the documentation and the videos, and actually with the project itself.
Oh, that makes sense. I mean, that's a very engineering perspective, or perfectionist sort of, I don't want to release this until it's perfect. And
Right.
if you didn't have deadlines, you might never release it because it will never be perfect.
Yeah.
Well, that goes back to motivation, and that's for a project that you're doing for yourself. Documenting things doesn't come
this
first
level.
to me.
No.
Yeah, I typically when I work on something, when I'm done for the day is when I do my documentation. And usually when I'm done for the day, it's about 6 a.m. So I'm not always most coherent when I'm doing my documentation, but I try.
So you mentioned the Raspberry Pi, but you've also got the Embed Nucleo on there as well. What is that doing?
Yeah, so I have 3 of the embed processors. They're the ST Micro, and I started off with the Nucleo development boards, but one of them handles the CCD for imaging, and that takes pretty much all of it to do that. The other one is for handling the grunt work, like moving the motors and handling, all of the housework involved. And the other one handles pretty much the interface. There's probably a way that I could have integrated all that down, but with the time frame and everything else, it was pretty much easier to do it that way.
Yeah, sometimes when you have more money than time, especially if you're only building one, it's easier to...
Yeah, and they're only
Simplify.
$10 a piece, so they're actually not pretty cheap.
Really?
Yeah,
I'm used to the embed boards with the NXP processors, and those are
those are expensive.
slightly freakishly expensive.
Yeah, the embed proper is like $60, I think.
Yeah.
Yeah, I started off with those, and I've bought several of them, but when the nuclear boards came out and it's only $10 for the development board, complete with a USB interface and everything, I mean, that's amazing.
I love the cheap dev boards.
Yes.
I remember when these things used to cost thousands of dollars.
Yep.
And now they're clearly not making money on them, and they may be losing in an effort to get us to buy their processors.
Yeah, and that was another nice thing is ST Micro actually contacted me, and
They did a write-up on you, too.
They did a write-up on me, and they were very, very supportive, and they were just great. Like, really, I have to say, they were amazing.
You said you were surprised at how many people were following you and sort of reaching out, wanting to help in some ways. Any good stories from that?
Oh, boy. From people, that's tough. There's been a lot. And actually, there's a couple of people that have contacted me, and they started off contacting me with questions about the CCD, actually, and have gone back and forth in emails, and it kind of turned into almost a collaborative effort in refining the code for the CCD and getting more integration time out of it and things like that. So it's been very helpful. And I was contacted. I mentioned about the aluminum for to replace the 3D printed parts. There's been people contacting me about that, about helping with casting and machining parts and things like that. So yeah, it's just everybody seems to have something to contribute, which is great.
So one of the things that I got excited about with your project is actually related slightly. It's something I've worked on in the past for a number of companies called optical coherence tomography, which I think I've mentioned on the show before. I don't know if you're familiar with it, but it involves spectroscopy as a part of the system. It's kind of a way to do microscopy for very high resolution through, say, skin or tissue. And what it can do is allow you to look with great detail at very small structures. And really short, the way it works is you either shine a broadband light source and some light gets scattered back from your sample and then interferes with your source. And then you can look at that interference pattern to determine the intensity levels of the scattering at various depths.
Yes.
And so you can keep doing that, and you can build up a whole image, a 3D image or a 2D image, depending on how you're scanning. And you can also do it with a swept source laser instead of a broadband source, and that's usually done with fiber optics. But when I looked at your project, I said, wow, this is really interesting, because I wonder if we could apply this to OCT and make a lower cost OCT system. And it turns out probably not, because the optical the light sources for OCT are much, much, much more expensive than, say, the rest of your optics. But it's still turning around in my mind, and I think this has applications. I think 3D printing of optical trains may have applications in a more broad sense, and I kind of got excited about that. And I wondered if you had been thinking along those lines. It's like, well, okay, we can do a Raman spectrometer this way. Can we do some other kind of spectrometer, or can we do this kind of scanner, and quickly get away from kind of the optical bench setup for prototyping, which can be very useful but expensive. I wonder if 3D printing would allow us to just quickly prototype things that are more stable and move to something that could be a product really quickly.
Yeah, I absolutely think that. I've been kicking around the idea in my head of other projects to start on it. I've thought of things like a 3D printed microscope, or definitely a standalone spectrometer, because the spectrometer that is included in the Raman Pi will actually work standalone by itself as a regular spectrometer. So seeing different ways to use that. So I definitely think that's a path that we could look at.
Well, I'll keep an eye on things. I'll see. It'd be nice if certain parts got more less expensive, but
Yeah.
For my applications, it's always dominated by a $10,000 or $15,000 thing.
Right. And actually the funny thing is when I first started and I was doing the original design, one of the things I thought of was just coming up with a sort of, a Lego set of optical bench components that are 3D printed and just make those available.
Yeah, I think that would be brilliant. But I don't know how much interest there would be in that generally. It's hard to gauge.
Yeah, it is.
Beyond a final system, because your final system is cool in and of itself, and there's big applications, but
even the optical, I mean, as you're making kits, that would be an interesting sub-kit of here's some optical widgets that usually cost $1,000 each, but since I 3D printed them and you're going to have to tune them a little bit yourself, now they're $20 each. That would be fairly magical. I mean, there have been times when we've prototyped stuff that it's hard to get the budget to start the prototype.
Yeah.
This would be a neat proof of concept before getting to machined aluminum. I don't know. I'm still so fascinated. But I think we are about out of time. Do you have, Mark, any last thoughts you'd like to leave us with?
I would like to thank everybody for the support, the interest, the Hackaday for all of their efforts, you guys for doing the judging. I mean, just everybody has been amazing, and I'm blown away. So I'm definitely going to be sharing more stuff in the future.
That's great to hear.
I think we're pretty blown away too. So yeah, feelings mutual. Thank you so much for chatting with us. And if you ever want to talk about that bigger project or you start looking at OCT, I'd sure like to hear more.
I will definitely contact you.
My guest has been Mark Johnson, creator of Ramen Pie and one of the Hackaday finalists. A link to Ramen Pie on Hackaday will be in the show notes, along with those excellent videos and build instructions. Let us know if you build your own. Email us, show@embedded.fm, or hit the contact link on embedded.fm. If you want to talk to Mark, there's a contact link on his Hackaday page, and he is on Twitter, which will be in the show notes. Thank you. Thank you to him for being here. Thank you to Christopher for producing and co-hosting, and thank you all for listening. Now remember, if you've got a talk proposal in mind, now is the time, especially if you want to be in Silicon Valley this spring or summer. The Silicon Valley Embedded Systems Conference, O'Reilly's Solid Conference, and the Embedded Linux Conference all have their due dates very, very soon after this show goes up. I'd say get them all in by January 9th and you'll be safe. Now, a final thought for this week from one of my favorite authors and scientists, Carl Sagan. Somewhere, something incredible is waiting to be known.